Yeah. You're welcome. Okay, so just a little reminder, I feel like that we can last a long time. So let's kind of get ourselves back on track here. We started with complex numbers, which I remember talking about how they came about. Remember, in the history of math, we always started with counting. So we had those numbers 1, 2, 3, and 4. But then mathematicians realized that, okay, if we combine the counting numbers in different ways, we can create new numbers like the integers, which include negative numbers, rationals when we start dividing, when we're finding like the side length of a triangle, or we're trying to solve x squared minus 5, for example, we build the real numbers. So we have those square roots going on. And then when we end up taking the square root of a negative number, the complex numbers started coming about, which is why we have this whole new set of numbers that we're dealing with. So that's kind of how this all came about. And we talked about, well, how do we combine these complex numbers, right? And essentially, we had this complex number that we called I, and I was the square root of -1, right? So that's all that means when we write the word I. And there was a very important property of I that I told you to memorize, and that was that I squared was -1. Okay, so whenever we see I squared, we're not going to write I squared. That's not the fully simplified version. We're writing -1 instead. Okay. Now, we realized that complex numbers kind of combine in a similar way to polynomials. So instead of writing x, we could write I. So we did a couple examples of that. They foiled the same way. We could solve equations with complex numbers. And then we got to more complex combinations of complex numbers, which is what we're going to talk about. Okay. So example number 2. We want to express this complex number in terms a plus bi, okay? And all this means is we want a complex number where there's like one real number and then one thing attached to the complex number I. We don't want multiple i's. We don't want an I squared. We don't want anything crazy, okay? So we have I times 3 minus 2i squared. Any ideas on what to do first? Oh, okay, so I see this. Very good guess here. So yes, says to distribute the 2 over. We wouldn't do that with a polynomial though, right? If we had like 2x plus 1 cubed, we wouldn't move the 3 over. We would write it 3 times and FOIL it, right? Yeah. Oh, okay, sorry. No, you're fine. I took what you said too literally. Okay, so why don't we do, I'm going to erase this because that is not the right thing to do. Why don't I take the I, and I'm just going to write the 3 minus 2i twice. Right, because an exponent means multiply something twice. Okay. Multiple different things we can do here. We can either multiply the I and the 3 minus 2i, or we could multiply the 3 minus 2i together. Which one do you want to do first? Yeah, I don't know why, but I think I like doing the more complicated looking ones first, just to get it out of the way. So let's multiply this together first. So we'll FOIL out the big term. But when you're doing that, remember to write the I, and don't forget about that I on the left, okay? So let's see, 3 times 3 is 9. We've got 3 times -2i, which is -6i. -2i times 3 is -6i. And then -2i times -2i is +4i squared. Okay, I'll move my parentheses over. Okay. Now it might be tempting to take that I and multiply it through, and that's totally okay, but let's try to simplify the inside. It might make it a little bit easier for us to simplify things at the end. Okay, so it looks like we got 2 6i's, so we can combine those together, right? So 9 minus 12i. What can I do with the 4i squared? -4, good. I'm gonna show the step because I always mess up. I don't know why, but instead of writing I squared, I'm gonna write -1. Okay, remember I squared is the same thing as -1. If you want to skip the step and write -4, that's okay, but I always mess up if I don't. So this becomes 9 minus 12i minus 4. Okay, and well, let's subtract the 9 and the 4. So 5 minus 12i. Okay. Where can we go from here now?
Now you distribute I.
Good, distribute the I. So I'm going to take the I and I'm going to multiply it by the 5, and I'm going to move over here. 5i minus 12i squared. Okay. Now what can I do?
Make 12 pi. 12.
Good, or write the I as a -1 because I always mess up, but good job there. All right, so instead of writing I squared, write -1. Okay, so this becomes 5i plus 12. Okay. Now, this would be fine. Some people like the convention of writing the number first, the real number first, and then the I second. You don't have to do this, but just for convention's sake, I'll do 12 plus 5i. Okay. Any questions on what I've done? All right. Example 2, a little bit more, I don't know, not as complicated. I think it's about the same. I'll give you a few minutes to work on example number 3, and we'll come back in a tiny bit. 3, Grace did a great job of writing out her answer. Do you kind of want to take us through your steps?
Sure.
Mhm.
So I did 3 minus 5i plus squared.
Mhm.
And I multiply that together. So 3 times 3 is 9. And then 3 times -5i is -15i. And then it's -15i again. And -5i times -5i is a positive 25i squared.
Mhm.
And then I distributed the negative to 5 and I. So it's -5 and -i. And I combined those terms together. So I did 9 minus 5 and that's a 4. And then I did -15i minus 15i minus I. So I eliminated there's one I. And then the 25i squared just turns into -25. And then I just combined the -25 and 4 and that -21 minus 39.
That's perfect. Nice job on that one, Grace. Any questions on example 3? All right, are you still writing it down? Okay. Yeah, so these aren't too bad. I think you kind of just have to be careful with like the negatives, making sure you're multiplying things out. But I think we're pretty good with these sort of examples. So let's move on to the next page. Okay, so we're going to talk about something slightly important here. We've talked about like what I means, and we know what I squared means, but we haven't seen I to the 3rd power, I to the 4th power, I to the 5th power, and so on. Okay. Let's talk about what those mean, and maybe why we don't see them as often, and that might give rise to some answers to these questions. Okay. Okay, so I have a little chart here, and I have I to multiple different powers. Okay. Now remember, I is the same thing as the square root of -1, okay? And square root powers, they work the same with negative numbers inside of them, okay? So let's just keep going. I to the 1st power is just I, right? Okay. I squared, we said was -1. Okay. What do you think I to the 0 power is?
1.
1, right? Anything to the 0 power is 1. Okay, now we have I cubed. Okay, if I want to find what I cubed is, isn't that I times I squared, right? I cubed is just I times I squared, or I times I times I. Okay, well, we know what I squared is. That's -1. So that's I times -1. So I cubed in its simplified, most simplified version is actually negative I. Okay, so we've got 1, I, -1, and -I. Let's see what I to the 4th power is. Okay, Well, I to the fourth power, isn't that I times I cubed? Right, so I'm just going to multiply the negative I times I. So that's I times negative I, which is negative I squared, okay? And negative I squared is negative 1, right? So I to the fourth power is actually just positive 1. Now I'm not going to require you to memorize all of these, and you'll see why. Let's do I to the fifth power, okay? Isn't I to the fifth power I times I to the fourth power? Okay. What's I to the fourth power? 1, right? It's on the chart, right? So that was pretty easy. So I to the fourth power is positive 1. So I to the fifth power is I. Okay, let's do one more. I to the sixth power, isn't that I times I to the fifth power? Okay, I to the fifth power using our chart is I. So this is I times I, which is I squared, which is negative 1.
Just repeat.
Yeah, right. So what do you think, Stephen? What do you think I to the seventh is going to be?
Negative I.
Negative I, right? Because I think you're noticing a pattern. What do we think I to the eighth power is going to be? 1, right? Okay, so I think we're seeing what's happening here. We're having a repeating pattern of 4, right? Negative 1, I, negative 1, negative 1. And then it just goes back to to positive 1 again, and we're going through this 4 cycle. So every fourth time, we have a repeat. So when we talk about powers of I, you have to know this one, I to the first power, right? And you have to know what I squared means. And of course, using exponent laws, we should know that I to the 0 power is 1, right? Now, I cubed is a little bit different. You can just multiply I squared times I to get this one, but you might want to memorize this one as well, okay? Once we have these guys, you don't really need to know the others, and they kind of simplify into the other ones, right? Okay, what we have is a repeating pattern of 4. We call this modular arithmetic. If any of you are computer science or math majors, you'll learn a lot about these repeating patterns that we call modular patterns. I'm going to be honest, when I was starting college, I had to learn about these modular patterns, and they went right over my head because I wasn't very prepared for college when I came here. So instead of telling you about modular arithmetic, I'm going to give you a couple steps on how to calculate powers of I. Keep it in the back of your head that this is modular arithmetic, so when you go into another higher level math class, maybe this will jog your memory on how to do those problems. Okay, but I have a little set of steps to doing this because I think it's easier. When we calculate powers of I, the first thing you're going to do is just write down the exponent that's attached to the I. Okay, so if it's I squared, you can write down 2. Then you're going to divide that exponent by 4 in your calculator. So divide it by 4, and you're probably going to get a decimal, okay? So what you're going to do with that decimal, ignore the whole part of that answer. So if it's like 15.25, ignore the 15, okay? Write down the decimal part of your answer. Okay, so let's say you wrote down your decimal answer and got 0.25. Then you're going to convert your decimal to a fraction over 4. And your answer is going to be I to whatever that number is. Now, I know that was really abstract, so let's do an actual example, and maybe it will make this seem a little bit easier. Okay, so example number 4, we want to simplify I to the 51th power. Okay, now that seems really crazy. Let's figure out if we can make this a little bit easier. Okay, so step 1, writing down the exponent attached to I. That's easy, that's 51, right? Okay. Step 2, divide by 4. Is there anyone who can go in their calculator and do 51 divided by 4? 12.75, great. Okay, so did that on your calculator, got this value. Step number 3, we're going to ignore the whole part of the answer, so the 12, and just write down the decimal part. So 0.75, right? What is 0.75 as a fraction over 4? 3 over 4, good. Okay, so step 5 is asking us what our answer is. It's going to be I cubed. Okay, now that's not our full answer because in our chart it says I cubed is actually negative I. You can either remember this or figure out how to get there, but negative I is the fully simplified version of I to the 51. Okay. Any questions on example 4? I know there's a lot of steps, but I feel like it's easier than going through what modular arithmetic is. Why don't you go to example 5, give that one a shot, and we'll come back in. I got Ainsley to write up her answer. Really good job here. Do you kind of want to go through your steps? Perfect job. Any questions on example number 5? All right, I think there's something like this on your test example, test review, so make sure you're looking at this for your exam. Yeah, I think we have enough time for this. So let's keep going. All right, so we're going to talk about conjugates. I think you've heard this term kind of floating around before, but we're going to spend a little bit more time on this. Okay, so when we're finding the, when we're dealing with complex numbers, every complex number has kind of like a pair that we call its conjugate. So for example, if let's say z, let me give an actual example here. Z equals 4 plus 5i is a complex number, right? It has a conjugate that we call z bar. Okay, so it has a little bar on it, which stands for the conjugate. And all we really do is we take the imaginary part and we flip its sign. Okay, so instead of 4 plus 5i, it would be 4 minus 5i. Okay, so we just kind of flip the imaginary part and we keep the real part the same. Okay, let's do a few examples that might be illuminating. What's the conjugate of 5 plus 7i? Oh my gosh. Good, 5 minus 7i. Okay, and then 5 minus 7i would be 5 plus 7i, right? So every number and its conjugate are conjugates of each other, right? So they kind of pair up. What do you think the conjugate of 4i would be? I think I heard it, negative 4i, right? The reason it's negative 4i is because isn't 4i just 0 plus 4i? Yeah, right. So if we want to flip the imaginary part sign, it would be 0 minus 4i, but we don't have to write the 0. So we just make it. Okay. What's the complex conjugate of 3? 3, good. And do you know why? Yeah, right. Isn't 3 technically 3 plus 0i, right? But the 0 is a 0, so we don't write it. If we flip the sign for 0, it would still be 0. So the conjugate of any real number without an imaginary part is just itself. So complex conjugates can have different forms based on like what the original number was. Okay. Now we have some properties of complex conjugates that you can memorize if you want to make things faster, but you don't have to. Okay. The reason we have conjugates is when we add a number to its conjugate, the imaginary part goes away. And if we multiply a number with its conjugate, the imaginary part also goes away. And we'll see that with an example in the future. If you want to memorize these, it's fine, but you don't have to know. Okay, so you don't have to know if you want to. All right. Let's see how these properties show up when we do actual examples. Okay, so here we have a complex number, but it's 1 over a complex number. When we see these in examples and such, normally people don't like complex numbers being in the denominator. Okay, that's kind of like a no-go. Okay, so when we simplify things, we don't want I in the denominator. Okay, so when we want to simplify these guys, we want to kind of take away that I from the denominator. We're going to use the conjugate to do that. Okay. So for this example, if I want to take the I out of the denominator, I'm going to do something weird. I'm just going to multiply it by 1. Okay. Just going to multiply it by, we can always do that. 1 times anything is itself. Okay. Now let's make it more complicated. Instead of writing 1 now, I'm going to write a different version of 1, but it still is 1. And it's going to be the complex conjugate of the denominator over itself. What's the complex conjugate of 9 plus 2i? Good, 9 minus 2i. So instead of writing 1, I'm going to write a glorified version of the 1, which is just 9 minus 2i over itself. We all agree that's 1, right? Perfect. Okay. Now, I'm going to show a couple extra steps just because my brain needs them. Let me just multiply the numerators and the denominators. So we got 1 times 9 minus 2i, 9 minus 2i. And in the denominator, we have 9 plus 2i, 9 minus 2i. Okay. What can we do in the denominator? FOIL, right? We can FOIL this out. So we can multiply the 9 and over on the bottom as well. Okay. If you memorize the formula, this would go a lot faster, but let's just go through the FOILing part. So we've got 81, right? Minus 18i plus 18i minus 4i squared. Okay. All right. Well, look what happens when we multiply by the conjugate. Looks like the minus 18i and the positive 18i cancel each other out, right? All right. So I think what we're left with is 81 minus 4i squared. But wait, there's more. Yes, there is more. What is more?
The I squared is -1.
Perfect. The I squared is -1. All right. So now we're eliminating that I from the denominator permanently. Good. You don't have to show this step, but I do it because I always mess up. So this becomes 81 plus 4 in the denominator. Okay. 81 plus 4, and please trust my math abilities in my head. I think it's 85. Perfect. Okay, so we eliminated I from the denominator. We are great. Okay, so this is a perfect answer to our problem. There's one other way you can write your answer if this doesn't look right to you. We can always split apart the numerator when we have subtraction. Okay, so you might see some people taking this and splitting it up into 9 over 85 minus 2 out of 85 times I. So it looks like A plus BI. You don't have to do that. You can leave it like the box version. Any questions on example 1? Yeah. The top.
Yeah, why are we not taking 2i?
Oh, that only works when we have I squared, right?
Oh,
Yeah, so I squared would turn it into positive 2, but it's only regular I.
oh,
Yeah. Good question, though. Any other questions on example 1? All right. How about I give you some time to work on example 2? Nice job writing this one out. Any questions on example number 2? All right. Let me check on time here. How about I quickly go through example 3 and then I'll let you go. Okay. All right. So example number 3. Let me just check on this. Yeah, okay, let's go through it. Okay, so example number 3. What am I going to multiply the top and bottom by? Good. The conjugate 3 plus 5i over 3 plus 5i. Okay, so multiply the top and the bottom by the same thing, and it's the conjugate that we're multiplying by. Okay, now you can do this in your head if you want. I like to write out the multiplication on the top and the bottom so I don't mess up. So we got 7 minus I, 3 plus 5i, 3 minus 5i, 3 plus 5i. Okay. Once we're here, we can FOIL out the top and the bottom, right? And of course, you can memorize the formula for this, but I like foiling it out myself. So on the top, looks like we have 21 plus 35i minus 3i minus 5i squared. Okay. On the bottom, if we FOIL, we get 3 times 3 is 9 plus 15i minus 15i minus 25i squared. So all I did was FOIL the top and I FOIL the bottom. Okay. Looks like the 15 i's can cancel out, so I'm going to cross them out right now. Okay. Looks like we can combine the 35 and the 3, right? So it looks like we have 21 plus 33i, right? Is it 32? Right, thanks. 30, oh my gosh, 32i. Gotta make a mistake sometime, right? And I squared is just -1, right? So let me combine that step in here too. Okay. On the bottom, looks like we have 9 minus 25 times -1. So I just replace the I squared with a -1. Moving on, looks like I can kind of clean up my real numbers now. I got 32i minus 5, and we have 9. Oh no, it's a plus 5, isn't it? Messed up. And then we have 9 plus 25. Okay, we're almost there. Looks like 21 plus 5 is 26, right? 32i on top, and 9 plus 25 is 34. Good. Okay, thanks. I'm very bad at mental math, but we got there. We can leave our answer like this. If you want to break up the fraction, that's totally okay, but I am fine with that answer. Any questions on example 3? All right. I will let you go. I will see you on Wednesday. And I'll post up the answers to that study guide. So